Hey guys, Mr. Grayson here. I was in Mexico. I am in Mexico, and it's amazing. I found a classroom here that looks almost exactly like ours. It's crazy. So because I found this classroom, I thought, you know what? Why not send some videos to my kids up in Vegas? I've just been running. That's why I'm wearing my running clothes and my hat. Good news is that they have a race here, so I'm going to do a race tomorrow. Let you know how I do. But yeah, we're gonna do some geometry. It's kind of tough to do geometry on this, but we're gonna try our best. So follow along in your notes, and then you're gonna have a chance to practice. So let's do this. We're gonna talk about circles. We're gonna talk about angles today. So there are different types of angles. Take a look at this paper. It is on your paper too. There are exterior angles, angles on the outside of circles. There are interior angles, angles that are on the inside of circles, and then there are inscribed angles, angles that are on the actual circle. And so we're going to talk about the different types of angles and properties of those angle measures. Now in your notes I've given you all the theorems, and we're going to do some example problems. So let's go through this right now. So we're going to start off with angles that are on the circle and properties of them. All right? So one of the main properties of angles that are on the circle is this. Theorem 1. If a tangent and a secant chord intersect at a point on a circle, then the measure of the angle formed is, technical difficulties. Never mind. Okay. Measure of each angle formed is 1/2 the measure of its intercepted arc. So, for example, what we have right here is we have an angle that is on this circle. So what we can say is that angle 1 is equal to 1/2 of the intercepted arc. And so the arc that it intercepts is BRD. So it's 1/2 the measure of arc BRD. Okay? And the same thing can be said of angle 2. So the measure of angle 2 is equal to 1/2 the intercepted arc. Am I saying that right? Intercepted, yes. Okay? And that is going to be arc BD. So it's 1/2 of BD. Okay? So that's a property of theorem that you need to know. So let's apply that, see what we can do with it. So what we have right here is we have a problem. Okay? And we want to know the measure of angle 1. Now the intercepted arc of angle 1 is right there. All right? So I know that an intercepted arc, okay, is 2 times the angle measure. So if I want to find the angle measure, I just take 112 and I divide that by 2. And 112 divided by 2, of course, is 56. All right, so the angle measure of angle 1 is 56. Okay, I think that's pretty easy. Let's try this one right here. Now this one's a little bit trickier because you have to do some extra steps. They give us the measure of this angle. They want to know what 1 is. Okay, but we don't know what the arc length for 1, so we can't find 1 yet. But what we can do is we can complete this puzzle to get, so we know x, and then we can find 1. So, 78. This right here is the intercepted arc. And I can figure out what that is. That's 78 times 2. And just to make sure my math is correct, let's do 78 times 2, and that is 156. So this arc right here is 156. All I did is I took 78 and multiplied by 2. I used my theorem. Okay. Well, that means I can find the rest of my circle because a circle is 360 degrees. So I just go 360 minus 156, and 360 minus 156 is 204. So x equals 204. Now, this angle 1 intercepts this major arc right here. So what we can do is we can apply our theorem and say, well, the angle measure is 1/2 of the intercepted arc. So angle 1 has to be 1/2 of 204. What's 1/2 of 204? That's going to be 102. So angle 1 is equal to 102. All right, go ahead, pause the video, and take 2 minutes and do the third one. All right, ready, set, go. Pause the video. All right, welcome back. Let's see if you got the correct answer. When I did this, my correct answer was, that's upside down, 236 and 124. All right, so that's theorem 1. Let's go on to theorem number 2. Theorem number 2. Okay, theorem number 2. Theorem number 2 is, okay, if two chords intersect in the interior of a circle, then the measure of each angle is half the sum of the measure of the arcs intercepted by the angle and its vertical angle. So, essentially what this is saying is that this angle right here, okay, AEB, it of course is congruent to CEBD because they're vertical angles. But there's a property with these arcs right here, these intercepted arcs. So what we can say is that these two angles, and I'm just going to write angle, so I don't have a lot of room, so I'm just going to write angle, okay, is going to be 1/2, okay, of the sum of my two arcs. So I don't have a lot of room, so we're going to go 2 arcs sum. Okay, so essentially what it's saying, and luckily you have it on your paper, is that these angles are equal to half the sum of this arc right here and this arc right there. All right, so let's see how this works. This problem right here. This problem says find x. So we want to know what x is. So we can use our theory. Well, I know that my angle is equal to half the sum of my arcs. And they gave us the two arcs that are intercepted. So what we do is we just go 107 plus 55 times 1/2. And let's see what that is. That is 107 plus 55 times 0.5 or times 1/2, and that's equal to 81. So x is equal to 81 degrees. All right, and that must mean this angle right here is also 81 because they're vertical angles. Okay, let's try another one. Number 2. This time they gave us an angle measure, and they said find one of the other arcs. So we have to set up an equation to find x. So let's use our equation here. I know that my angle measure is 71, and it's equal to 1/2. Okay, it's equal to 1/2 my two arcs, the sum of the two arcs. So I just go 92 plus x. Okay, so what we have to do is we now have to solve this equation. So we have to distribute the 1/2. So that's equal 92 times 0.5. That's equal to 46 plus 1/2 x. Right? Bring down the 71. Again, I don't have a lot of room. You should know how to solve an equation like this, though. So I'm going to subtract 46 to both sides. So go ahead and do that on your paper. So 71 minus 46. That gives me a 25. And then I have half of x. So 1/2 x. So that means I'm going to divide both sides by a half. Or you can multiply by the reciprocal, either way. Divide both sides by half. So 25 divided by 0.5. That's going to give us a fixed 50. So x is equal to 50. That is the arc length. All right, go ahead, pause the video, and try the third problem right now. Go ahead, go for it. Okay, welcome back. This was a tricky problem. Let's see if you were able to work it out. What made this problem tricky is you had to find the up and down, let's just show you, the up and down vertical angles first because they gave you these two arc lengths. So what we had to do is we had to add these two things together and then divide by 2 or multiply by half, and that gave you 114. And then since this complete thing, and this is going to be hard to see right here, is a 360 degrees all the way around that dot, I know the other two angles have to be equal to each other. So what I did is I subtracted 360 minus 114 minus 114, and that gave me 132. And since there's two angles, I had to divide by 2, and that gave us a 66. So that's a pretty tricky problem. Hopefully you were able to work your way through that. If you're not, and then there's a lot of people confused, go ahead and pause the video and maybe have somebody that got it explain it. All right? Okay. Let's go on to theorem number 3. And this is the last theorem today. So you're only doing 3 theorems today. All right, let's check it out. Theorem number 3. Okay, theorem number 3, it's on your paper. Let's read it. If a tangent and a secant, 2 tangents or 2 secants, intersect in the exterior of a circle, so we're talking about exterior angles, then the measure of the angle formed is 1/2 the difference, important difference, of the measure of the intercepted arcs. Okay, so essentially what we're saying is we're saying angle E, we're going to call it angle E, so I have space, is equal to, okay, 1 is equal to the difference divided by 2. So what we would do is we would take AB minus CD and divide that by 2. So you take this arc length right here minus that arc length right there, the smaller one, and you divide it by 2. So let's go ahead and practice and apply that theorem. All right, so what we have right here is we have an exterior angle, and we have 2 arc lengths. So what we do is if I want to find this, I want to find x is equal to the difference of your arcs, so 93 minus 29 divided by 2. That's pretty simple math. Throw it into your calculator. 93 minus 29 divided by 2, and that should give you 32. Boom. Pretty simple, right? Going to get a little bit more complicated, but don't freak out. This time they gave you the angle measure, and they're saying find the arc length. Find that missing x. So let's go ahead and try that. So what we have is we have 59. I know what the angle measure is, so 59 equals 168 minus x. I have no idea what that is. Divide by 2. All right, and that's just an equation we can solve. So what we do is we multiply both sides by 2. These 2's cancel. 59 times 2 is 118. Is equal to 168 minus x. Okay. Subtract 168 to both sides. So 118 minus 168. That gives us a negative 50 is equal to negative x. And it's easy to get rid of a negative sign. You just divide by negative 1. And that means x is equal to 50. All right. Those are the 3 properties. Pretty easy. If you need to review them, go back through and read them. What you're going to do now is you're going to turn to the next page in your packet, and there's going to be tons of circles that you're going to practice this on. All right, so go ahead and practice. Tomorrow is going to be a practice day. You're not going to learn anything new. You're just going to practice this again. Please don't work ahead. If you do, you won't have anything to do tomorrow. So have a wonderful day. I'm going to go scuba dive in Mexico right now because that's where I am, because it's awesome. And I will talk to you guys maybe tomorrow. We'll see if I can make another video.